Hello and welcome. We are live at the Guiana Space Center. I'm Guido Levrini from the European Space Agency and I will be your guide this evening. This launch was originally scheduled for the 22nd of April. We had to postpone it already 3 times. Tonight is our 4th attempt. We had to postpone it 2 times due to the weather, high altitude winds, and last night due to the anomaly with the launcher, an anomaly which is now fully understood and corrected. All is fine now and we are set to go.
Ladies and gentlemen, welcome for our 3rd launch of the year from the Guiana Space Center, the first with Soyuz. For today's mission, Soyuz is set to deliver several satellites into low Earth orbits, all inclined at 98.2 degrees with respect to the equator. Sentinel-1b is another satellite of European Commission's flagship program, Copernicus, dedicated to sustainable development, alongside to support humanitarian aid and crisis situations. Then, a second set consisting of 3 CubeSats will be separated about 2 hours and 48 minutes after liftoff on a lower and slightly elliptical orbit. These nanosats were designed and built by European students in the frame of ESA Academy Flyer Satellite Program, an educational initiative to foster science and technology careers in Europe. Microscope is a 300-kilogram scientific spacecraft designed and built by the French Space Agency, CNES. Its purpose is to verify and possibly challenge the principle of equivalency between inertial and gravitational masses. It is always a source of great pride for Arianespace to provide European institutions with independent access to space thanks to our launch vehicle family. Tonight's mission is emblematic of such ambition. So, let me express my deepest gratitude to the European Space Agency for its unwavering support to our activities, to the European Commission, Arianespace's first institutional customer through contracts with ESA, for its continued trust in our launch solutions, both for Copernicus and for Galileo. To CNES for involving Arianespace in its science endeavors, as thrilling as that at stake tonight with Microscope. But our 14th Soyuz to be launched from the Guiana Space Center is now ready for liftoff, so enjoy the show.
We have 3 missions to launch tonight for a total of 5 satellites. The primary mission is Sentinel-1b, built by Thales Alenia Space of Italy for the European Space Agency and the European Commission. Sentinel-1 is part of a flagship program, Copernicus. The second mission is a science experiment called Microscope from the French Space Agency, CNES. And the third mission is an ensemble of 3 little satellites made by students, whose work has been coordinated by the ESA education program Fly Your Satellite. A particularly big welcome to all of the young people watching the launch. And here we see the protagonist of the evening, the launcher Soyuz, which is built of 4 stages. From the bottom to the top, you see the boosters, the 3rd stage, the 2nd stage, the 3rd stage, and now Fregata. We'll talk about it later. This is the fairing which contains our satellite. On the very top you see Sentinel-1b, the biggest one, and below Sentinel-1b now you see Microscope, which is inside the structure which supports Sentinel-1b, 2.2 tons. And this is Mission Control, Stéphane Israel, CEO of Arianespace. This is where the difficult decisions are taken when something does not go exactly as planned. Sentinel-1b is part of Europe Copernicus program to better understand our planet. It consists of 6 families of Sentinel satellites.
Ladies and gentlemen, today we are going to launch another Sentinel satellite. Just another one? It's Sentinel-1b. No, it's more than just another one, because it's one out of 2, a pair of Sentinel-1a and Sentinel-1b. Both are looking to the Earth with radar instruments, being able to look to the Earth during night and also during cloudy weather. And Sentinel is more than just Sentinel-1. It's a fleet of Sentinel. It's the 4th already which we launched today. And the Sentinel satellites are part of the Copernicus program, which we deliver together with the European Commission for Earth observation of the future. With that, Sentinel becomes already an operational system for Earth observation. And by having 2 satellites of the same type, we can reduce the revisiting time dramatically. And Sentinel data is already used by the general public and by companies worldwide, because we have the free and open data access in Copernicus, so it's not only the European user, but worldwide the data of Sentinels are really of big use. So I hope that we will have a successful launch later on, and I wish you a very nice evening today in Kourou.
Sentinel-1b arrived here on the 8th of March by plane. Microscope followed a couple of days later, and 2 weeks later also the 3 CubeSat arrived by plane from the technical center of the European Space Agency in the Netherlands. They were carried as hand luggage. The 5 satellites were integrated here with the launcher at the CSG in what is known as the launch campaign.
The launch campaign Soyuz VS14 began on March 1st with operation on the upper stage frigate in the MiG building. During the first 3 weeks, pneumatic and electrical tests were performed on board.
The first 3 stages of Soyuz were assembled horizontally, starting with the 4 boosters, which were strapped to the 2nd stage, followed by integration of the 3rd stage. On the 8th of March, Sentinel-1b was transferred to the clean and secure environment of the S5C complex. Here, teams performed a series of tests and checked the good health of the satellite before filling the tanks. 2 days later, Microscope arrived and started preparations.
After filling of the tanks in the F-Cube, frigate was transferred in S3B in order to perform the combined operation with spacecraft.
Microscope was integrated with the adapter called ASAP-S. Then it was the turn of the Fly Your Satellite CubeSats to take their place in their separation system. The ASAP-S, with Fly Your Satellite and Microscope attached, was then assembled on the frigate upper stage. Sentinel-1b was then attached on top of the ASAP-P. The whole stack was carefully hoisted and encapsulated inside the protective case of the fairing. Early on the 19th of April, the first 3 stages were transferred horizontally to the pad and raised to a vertical position. Later that afternoon, it was the turn of the upper composite to be transferred from the satellite buildings and integrated with the Soyuz, ready for launch.
And we are approaching the final stages of what is called the frigate automated sequence, the last 10 minutes of 20 seconds of the countdown. This is where the onboard computers are running all the final operation. Here we see the Norwegian Jon Hard, our range operation manager tonight. So we had a delayed launch, first due to the weather. Due to high altitude winds. I have to tell you, it's been raining cats and dogs here. I mean, we are at the tropics, but rain does not stop us for launches. It was the Hailus god of the winds who was not with us. And yesterday there was a technical issue with the launcher, issue which has been resolved completely by now. So all satellites are safe in the fairing on top of Soyuz, and we're set to go for this evening. you see the teams, they are highly concentrated after 4 days waiting time. So we heard about Sentinel-1b. Let's get more information about the other two missions.
VS14 mission is a multiple launch configuration which hosts also 2 auxiliary passengers for a total of 5 spacecraft on board. Among the auxiliary payloads integrated on the ASAP-S structure, Flyer satellite payload includes 3 small satellites. Piero, you are the head of the ESA unit which coordinates all programs for university students. How did you come to this launch opportunity of the 3 CubeSats which are part of Flyer satellites?
Short after the first ESA CubeSat mission launched on the Vega maiden flight, ESA started the new Flyer satellite educational program with competitive call for proposals for CubeSats built by university students. By mid-2012, 6 CubeSats were selected. Finally, the 3 CubeSats of this launch are those that were able to meet the Flyer satellite program requirements and that achieved flight readiness. This launch opportunity was made possible thanks to Sentinel-1b that accepted to include the launch of these CubeSats in their launch contract with Arianespace.
Among the auxiliary payloads integrated on the ASAP-S supporting structure under the fairing, Microscope is a 300-kilo class microsatellite which has been integrated in the central position below Sentinel-1b main passenger. Microscope is a microsatellite dedicated to fundamental physics experience.
Valerio, CNES initiated this ambitious project, the Microscope project, 16 years. Can you tell us something about Microscope?
Microscope is a scientific microsatellite dedicated to a fundamental physics experiment, the measurement principle of equivalence between inertial mass and gravitational mass. Developed by CNES, it was designed, validated and assembled in the premises in Toulouse. Onera has provided the instrument while ESA contributed to the mission by delivering the microthrusters and its control electronics. CNES is also responsible for the system and operations. A key feature of the satellite is a strong coupling between the payload and the platform, which is taking part of the performance of the mission.
As responsible of satellite, can you tell us what this launch means for CNES?
This is the outcome of a considerable human commitment. Last 2 years have been particularly intense to be ready by appointment by Sentinel-1b. I was appointed satellite manager in 2009 when it was decided to change the propulsion system. I fully measure the progress made since that point and all efforts made to achieve the goal tonight. We thank the teams of Arianespace and CSG for their welcome and their support through the campaign.
Thank you, Valerio.
And we just had the confirmation that the last meteor sampling was positive, so the weather is green tonight, and we are really set to go for Rio. You see the mission control, but there is another control center here at the CSG. The CSG, you see the path now, the CSG is a very large area. It hosts the 3 families of launchers which are operated at the base. Ariane, the largest, Soyuz, and Vega. Each one which is own launch pad and launch facility, so it's a little bit like operating 3 different launch bases. It covers a very large area which is just over half the size of my hometown, Rome. Here you see a joint team of Russians and Europeans working side by side. This control room is inside a protected building which is about 1 kilometer from the path, and it is the launch control room. And we are reaching the point that we call key on start, Kruch na start in Russian. It is the final phase of the Soyuz automated sequence. It lasts 5 minutes and 20 seconds.
For tonight's launch, we use Galileo, the CSG station of CSG in French Guiana, two Canadian stations, Saint-Hubert and Saskatoon, the Indian station of Lucknow, and finally, a station located on Mauritius Island in the Indian Ocean. These stations allow us to follow the launcher during the main phases of the flight, and because of the duration of the mission tonight, each of them will be used at least 2 times. The data collected by these stations are sent in real time to the CDLS, the Soyuz Control Center in French Guiana, and to the Frigate Flight Monitoring Center in Moscow. And the parameters that are the most representative of the functioning of the launcher are monitored by a set of technical experts from Arianespace and from its Russian partners. These data concern the propulsion of the launcher, its trajectory and the flight control. They are compared to the forecast throughout the flight, and a continuous synthesis of the launcher behavior is done for the high management in Jupiter and for the launch teams in the CDLS. This is what we call the CVI, or the Instant Visual Control. This real-time monitoring is really important, as it allows to check that the flight is nominal and to confirm our customers that their satellites were separated as expected.
And this is mission control, and here we see the launch pad. You see this big gray metal mast is called Upper Composite Umbilical Mast, or KZM. You're going to see it pull it away just before the launch, 35 seconds before the launch. Umbilical means that inside there are the umbilical lines that take info from the satellites to the team on the ground. When it is disconnected, it means that our satellite will not be powered by the ground any longer and will start to survive on its own, will be powered on its own batteries. And Sentinel-1b will stay on its own batteries as long as, after separation, has not deployed its wings, has not opened its solar array, reaching what we call a power positive state, meaning more power comes in that is needed to survive. A word on the ignition sequence of Soyuz. Soyuz, there is a system for checking the health of the engines before it leaves the pad. It ignites all 5 engines 17 seconds before liftoff. There are 4 on the 4 boosters and 1 on the core stage. They are throttled them up gradually, gently, to check that engines are all working fine. Remember that Soyuz also carries people, not tonight. So, when they reach full thrust, then you will see the vehicle leaving the pad. Moments of very high concentration for all of the teams that have been working so hard.
À tous de DDO. Attention pour moins 1 minute. Top. H0, moins 1 minute.
And we are 1 minute to launch. We are live at the Guiana Space Center, and we're launching Sentinel-1b, built by Thales Alenia Space of Italy for the European Space Agency and the European Commission, part of the Copernicus system. We are launching Microscope, a scientific satellite of the French Space Agency, CNES. And we launched 3 small satellites built by students under the ESA program, Fly Your Satellite. Our best wishes to all of the teams.
Attention pour le début de la séquence d'allumage du lanceur. Top. H0-20 secondes. Largage du VKM. Allumage du triétage. À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Décollage, lift-off, VS14.
And we are
Les paramètres
off,
à
we
bord
are
sont
off,
normaux.
hauling ourselves against the gravity of the Earth. 336 tons, the equivalent of 22 buses. And we're heading north, out over the Atlantic, and then over North Canada. So at the moment, Soyuz is burning its 5 engines, 1 on the core stage, 4 on the boosters. The boosters are doing most of the work. Their job is to get us away from Earth and defeat gravity, which makes us stick to our planet. They have a very short-lived
Le
job.
vol est nominal, les paramètres sont normaux.
All parameters are nominal. They have a short life. They're going to be separated, and you will see them drop on the ground just before 2 minutes in the flight, so very soon. They are powered by liquid oxygen and kerosene. If we get lucky, we should be able to see the separation of the boosters, which is a magnificent sight.
La propulsion du premier et deuxième étage est nominale.
All is nominal on board. Watch for 158. Separation of the boosters. You can't, but I can see the roar
Séparation des
of the
boosters du
engine
premier
from
étage.
where I'm staying. So the burn of their propellant, so we don't need them anymore. They fall back to Earth, and we are shedding weight, which is the whole trick of a launch. The lighter we are, the faster we go. So we are start to burn the second stage, or the block A. This will burn for just under 5 minutes.
La
If you
propulsion
look
du
at
deuxième
the
étage est nominale.
trajectory, as we call it, this curve on the right upper corner of your screen, this shows the theoretical path that we are following tonight and the actual path, this white dot.
Le
So as you see,
déroulement du vol est
everything
nominal.
is nominal. We are coming now to the altitude. Look on the bottom left, where we can get rid of the fairing. The fairing has these 2 shells that protect our precious payload. They protect it from the acoustic vibration at liftoff, the very loud noise, the roar of the engine, and from the friction, the resistance, the pressure, then the air layer are here we go, are exercising on the launcher during the ascent. Here they go, we have jettisoned the fairing. We don't need it anymore. We are now outside the atmosphere. And if someone asks you how much time it takes to go to 700 kilometers, answer, 23 minutes. This is what it will take us today. So probably less than what it takes every morning to go to work. So we have seen our satellites for the first time, and this is always an emotional moment, even when it is only computer-generated images. Here we see the teams. I'll tell you, they've really worked hard in all these days, and they kept the concentration, and today is the day.
La propulsion du deuxième étage est normale.
So we're coming to the point where the second stage will be shut down, will be falling away, and we will start igniting the third stage. Here we go. We are now burning the third stage. So we launched Sentinel-1A 2 years ago, and we're launching its twin tonight.
Séparation du deuxième étage. Séparation de la butte. Interétage.
On the 14th of April 2014, the European Space Agency launched the first of its new line of Sentinel Earth observation satellites, Sentinel-1a. It was sent into orbit on top of a Soyuz rocket from the European spaceport in Kourou, French Guiana. Now, almost 2 years on, it's time for Sentinel-1b, its identical twin brother.
Sentinel-1b is the first of the second satellites, so to speak. We have already launched the so-called A satellite, and this will help us to have the double amount of data, or only half of the time to wait. In practice, we can get from any place on Earth, we can get within 6 days an image with the A and the B units together.
To achieve this, both satellites will be flying in the same polar orbit, 180 degrees apart, working together as a constellation. They carry a powerful synthetic aperture radar, or SAR instrument. This radar allows the satellite to provide images of the Earth's surface under all weather conditions, day and night. The unprecedented speed and resolution of the Sentinel satellites is providing an unparalleled amount of data, making it a true success for the scientific community worldwide.
It has gone far beyond our expectations. Besides some 80 services which are operational and also supported by the European Commission, there are now national services emerging, and we have 27,000 self-registered users who have downloaded already 500,000 of images, and I tell you, you don't download a radar image if you don't really need it.
The radar images provided by the Sentinel-1 satellites will allow scientists to detect small changes in volcanic activity, routinely map sea ice to help ships navigate through our increasingly crowded polar seas, and allow a better management of shipping routes worldwide. These are but a few examples of the services provided. Sentinel-1a and 1b are not the first satellites monitoring our planet, but they will be the first ones to do this continuously as an operational tool within the Copernicus program.
This is a real game changer, if I can say that. We want to do now, or we do now, what we have done 35 years ago with the meteorological system, operational satellites. That means we will ensure for many, many decades operational services. And this ensures, on the other hand, the users that they invest in new applications, be it governmental or be it private.
The Sentinel-1 satellite mission is an important part of the European Union Copernicus program, for which ESA and the EU are planning to deploy 6 families of Earth observation satellites. Each of these families will address specific needs, and all will provide crucial information to better understand our planet. The information can help mankind to plan a sustainable future for itself and the planet we all share.
And you have heard Professor Liebig, the Director for Earth Observation Program at ESA, explaining which wealth of data Sentinel-1a is already delivering in its 2 years of operation. And with the arrival of its twin that we're launching tonight, and with increased exploitation of Sentinel-1a, by the end of the year we will deliver to the user 3 times the amount of data we are delivering today. And you've seen this is the moment of the third stage engine shut down. We have separated it, and now it's Fregat who takes us to orbit. Its job is to deliver our satellite to their drop-off point in space. Tonight he has to deliver 3 separate missions, and it's going to take about 1 hour to do that, so quite a journey. Let's explain what will happen. First, we're going to climb to about 700 kilometers altitude, which is the drop-off point of Sentinel-1b. Then we will go down, and we will go down by more than 200 kilometers to fly a satellite. We will then climb up again to just above the 700 kilometers when we left Sentinel-1b, to separate microscope. You've seen now that the first burn of Fregat has started. This last just over 10 minutes, and the satellite is now being acquired, sorry, not only the satellite, the upper composite frigate has just been acquired by the station of Saint-Hubert. Our flight path tonight takes us north, so we are over northern Canada, and it is there, not yet, where we will separate Sentinel-1b. Why are we flying north? Are we flying north because we are launching an Earth observation satellite, Sentinel-1b. An Earth observation satellite have to be able to cover the complete globe, and they do that by being placed on an orbit which goes over the poles and exploiting the rotation of the Earth beneath them. They cover the whole globe. It's like peeling an orange slice by slice. So Sentinel-1b was built by a consortium of European companies led by our friends at Thales Alenia Space in Italy. They are great experts in Earth observation and in radar system. So they're very proud of their contribution to understanding our planet.
This is a great day for all of us. The Sentinel-1b satellite program development is a success for both Europe and our company. It's another step forward for Europe's flagship program that will provide crucial climate data. More than 400 Thales Arianespace engineers and specialized technicians in Rome, L'Aquila, Milan, Madrid, Charleroi, Toulouse and Cannes have given their best and their top quality work to this program. As you know, Thales Alenia Space is prime contractor for the Sentinel-1 satellite, and this launch is particularly significant for our company. All the more so because we have recently signed further satellite contracts with the European Space Agency in order to guarantee the continuation of the Sentinel-1 and Sentinel-3 missions. We are very proud to have been a partner in the Copernicus program right from the beginning, working on increasingly sophisticated observation missions with ESA, ASI, CNES, as well as other national space agencies and European Commission, and represents the most complete solution to the technological challenges that such ambitious program require. Thales Alenia Space is ESA's main supplier in the Copernicus space segment. So let me express my warmest thanks that go first to all the European Space Agency, the European Commission, Arianespace, and then to all the teams who have worked so hard in this mission.
Space is about cooperation. Space has no frontiers. Copernicus is the result of a successful cooperation between the European Space Agency and the European Commission. And Sentinel-1 is an example of industrial partnership between two companies, Thales Alenia Space and Airbus Defence and Space, that any other day where they do not work on Sentinel are competitors. Sentinel-1b is part of a huge program called Copernicus. It's implemented by the European Space Agency for the European Commission, and it consists of 6 families of Sentinels called satellites. Several families because we need several techniques, several technologies. Copernicus is a system that aims at performing a complete health check of our planet. This is why we use very many different technologies, like the difference between a blood test and a full health check. So Sentinel-1A is really changing lives in a very tangible way, and its twin, Sentinel-1B, that we're launching this evening, is going to make those services even better.
Soon Sentinel-1b will be put into orbit working as a constellation with Sentinel-1A. Both satellites will gather operational data for Copernicus. the European Union's Global Monitoring for Environment and Security program. This program aims to offer users from around the globe satellite and institute data, along with dedicated services. Already we can see that this data is changing the work of many institutions. Here at the Danish Meteorological Institute, the DMI in Copenhagen, Copernicus data has definitely an impact on the activities.
Copernicus is changing our work in two ways, both that it has provided us with a platform to combine all the data that we are collecting, but also in the sense that we can now provide a better service to our users because we now have funding to produce these forecasts that our users are asking for, the forecast for Danish waters, for the ocean currents, for the salinity and temperature.
One of these products that the DMI produces are ice charts for the Nordic waters. This process of receiving environmental data and making ice charts is key for living in the Arctic regions. With lives of people working and traveling at sea at stake, it's necessary for the DMI to track the position and thickness of sea ice on and around the shipping routes. The creation of these ice charts greatly benefits from the new Sentinel-1 data.
Well, we get especially Sentinel data from ESA. We use that to make ice charts of Greenland. Especially in the wintertime, it's very dark in Greenland, so the good thing about Sentinel is that it's radar imagery, so it doesn't matter whether it's dark or it's daylight. Also in periods with bad weather, where we have a lot of clouds in Greenland, you can still see through the clouds, so we can see where we have ice and where we have open water. And then we make these ice charts that we send to the vessels sailing around Greenland, but also between Denmark and Greenland.
Where in earlier years the DMI had to rely on planes, helicopters and the occasional satellite to gather less than optimal data, the use of the Sentinel-1 data has been a game changer. These high-resolution radar images are not only useful in all weather conditions, but also their frequency and coverage is an important factor. Today, the gathering of data by Sentinel-1A already happens at a very high frequency, but this will double with the launch of Sentinel-1b. The timely images of the Sentinel-1 satellites allow the DMI to keep ice charts much more up to date.
I think having access to Sentinel-1 images means that we have a much more flexible approach to our work. We can make our ice charts when they're really needed. When we know vessels are entering Greenland waters, so when they're reaching certain areas, we can make ice charts because now we have images almost every day of the Greenland waters.
This process of ice mapping is an excellent example of the difference the Sentinel-1 satellites can make. But they provide many other services as well, such as forest mapping, detection of oil spills, volcanic activity measurements, and disaster monitoring. The Sentinel-1 satellites and their services are a perfect illustration of the goals of the Copernicus program. An operational monitoring tool for our environment with services for thousands of users worldwide, all working together to protect our planet and its people.
So we have heard about some of them, but the list of applications of Sentinel-1 is almost endless. It carries an advanced radar. This means it can see through the clouds, it can take measurement day and night. It does not need the illumination from the sun. This makes this mission particularly suitable and helpful for natural disaster and emergency crisis situations such as earthquakes and floods. But the list of applications continues. It is extremely good at detecting very tiny movement in the order of millimeters, imagine from 700 kilometers altitude of a terrain. We call it subsidence, either due to extraction of gas or fracking or natural subsidence itself of the terrain. It is capable of monitoring the stage of growth of rice, and rice is among the 3 most consumed crops to feed world population which is constantly growing. We reach 11 billion by the end of the century. Over the ocean, it adds navigation by providing information about winds. It measures waves. It can monitor oil spills, both from ships and oil platform, provide assistance to ship routing and fisheries. And I could continue. So very many applications, each of which taken individually would justify the investment. and Sentinel-1 delivers all of them. And here we come to the point where Frégate is switching off its engine for the first time. This is the end of the first and longest burn. Look at the bottom left side of your screen and you will see that we have reached the right altitude, the orbit of Sentinel-1b. This is the right altitude to complete the first task, separating Sentinel-1b. What is happening at the moment is that we have entered what we call a ballistic phase. It will last about 3 minutes and 20 seconds until we come to the point of separation. It is ballistic, it means it is without propulsion.
Extinction du frégate.
We are traveling high enough and fast enough to cruise without the engine. What you're seeing Frégate doing at the moment is what we call orientation maneuvers. This means that Frégate, which is a very versatile machine,
Début des manœuvres d'orientation au profit de Sentinel-1b.
Frégate will now orientate itself in order to
Acquisition
be
de la télémesure lanceur par la station de Saskatoon au Canada.
So far, everything is proceeding nominal. So we were saying Frégate is now orienting slowly itself to prepare to deliver in orbit Sentinel-1b. It will deliver Sentinel-1b not only just on the right orbit, but with the right attitude with respect to the Sun, so directly in its own operational orbit. Frégate is an extremely versatile machine. It was originally designed as an interplanetary probe in the 90s. It first flew on Soyuz in
Tous les
2000.
systèmes bord fonctionnent nominalement.
Everything is nominal, and this is just we want to hear tonight. Frégate is capable of switching the engine on and off 20 times, and this evening is going to do it 5 times for us. It can take passengers wherever they need to go. It's an excellent taxi, first-class taxi. So, let me explain now that we're coming close to the first key milestone of the evening, a crucial moment for the Sentinel-1b team. It is the moment of separation of Sentinel-1b. It is scheduled for 23 minutes and 35 seconds in the flight. We are coming close to it. The confirmation of the separation has to go via a number of technical checks that must be very accurate. And because Soyuz and Frégate are a Russian launcher, let's not forget this, all these checks have to go via Moscow. This means that it may take a little bit before having the official confirmation here in the mission control room of the separation. And here we are. So, Sentinel-1b, high up in space, is separated from Frégate, but we need to wait to get the confirmation of the separation from the launcher side. The launcher is seen by the ground station of the launcher network, but soon after the satellite is separated, it starts sending signal to home, to the station of the satellite network. And the first station that you will see is Svalbard. Svalbard is located in northern Norway, and this signal is immediately routed to the control center of the European Space Agency, which is located in Darmstadt in Germany, and is called ESOC, European Space Agency Operations Center. There we will see the Sentinel-1 mission director, Pier Paolo Emanueli, giving the confirmation that he has received the what we call the acquisition of signal, meaning the satellite talking to home and saying, hello, I just took a short nap, 20 minutes, not more, now I wake up and I'm ready to start my mission.
Séparation du satellite Sentinel-1b vu par le bord.
We had confirmation of the separation. It's a great emotional moment, of course, for all of the teams, and in particular for the Sentinel-1b
Fin de
team.
visibilité du lanceur par la station de Saint-Hubert. Perte normale de la télémesure temps réel.
And this is the image of the control room in Darmstadt in ESOC when you see the team at work. And now their job really starts, because as far as Sentinel-1b is concerned, now we have a very busy night while Fregat continues his job. We need to deploy our solar array, we need to deploy our radar antenna, so the job for our friends in ESOC has just started. We cannot hear ESOC, but I can tell you we had separation from the satellite, and the satellite is healthy and talking to home. We see Pier Paolo Emanuelli, who is the Sentinel-1 mission director at ESOC.
Okay, I don't know if you can hear me from Kourou, from ESOC. I think that I already confirmed that we got the satellite. We had the OS in Svalbard. Sentinel-1b is talking friendly to Darmstadt, and the parameters looks nominal at the moment. The auto sequence start triggering in a nominal way. Now we start a sequence of important operation in Darmstadt. We will have power positive, as Guido said previously, at a mission elapsed time 5 hours and 22 minutes from now. Then we will go through a series of deployment that will finish in 10 hours from now, more or less, and in 23 hours we will be with a spacecraft three-axis stabilized in the nominal mission attitude. When we will reach MET 32 hours, the spacecraft will be able to maneuver, and everything, if everything goes well, and nominal.
Everything went absolutely nominal. Everything worked like a clockwork. Space is adventure, space is fascination, but space is also endurance. And the endurance of the team in the last few days and in these last years have paid off. Now we are repaid by a successful launch and separation of Sentinel-1b on its orbit. And now Sentinel-1b starts his own life while Fregat has to continue doing his job. He has still 2 missions to deliver in orbit this evening.
Première acquisition du satellite Sentinel-1b confirmée par les clients satellites.
This is a confirmation that, again, Sentinel-1b has separated correctly. Okay, we are now coming close to the official speeches after the separation. So I will leave you for a few minutes. Stéphane Israel, the CEO of Arianespace, will now make his speech.
Bien, mesdames et messieurs, monsieur le préfet, ladies and gentlemen, distinguished guests, Arianespace is Mesdames et messieurs, monsieur le préfet, ladies and gentlemen, distinguished guests, Arianespace is delighted to confirm that Sentinel-1b has been safely separated on its targeted sun-synchronous orbit. We have thus achieved successfully the first step of tonight's long and complex mission, entirely dedicated to European space-based application. Indeed, while Microscope and the 3 Flyer satellite CubeSats are continuing their journey into space, Sentinel-1b is already starting its preparation to soon provide European citizens with all-weather day and night radar imagery to be used especially for land and sea mapping. Sentinel-1b is the third satellite launched by Arianespace to deploy Copernicus space segment. Through Copernicus, Europe is developing its own global monitoring system to better address our environment and security issues, an objective which is fully in line with our ambition to put space at the service of a better life on Earth. So, let me express my deep gratitude to the European Commission, to Commissioner Bieńkowska, and to DG GROW for entrusting Arianespace with the launch of Sentinel-1b. This launch is the first of 3 dedicated this year to Copernicus and to Galileo. We are very excited by this perspective, and we will deliver. I want for sure to extend my gratitude to the European Space Agency in charge of Copernicus space component, and as such, our direct customer for this launch. Many thanks to ESA DG, Jan Werner, and to Volker Liebig, Head of Earth Observation Programs at ESA, for their continuous trust. Last but not least, I would like to congratulate Thales Alenia Space in charge of Sentinel-1b design and manufacturing. This was the 144th TAS satellite launched by Arianespace, and we have a lot to deliver together. Before going back to mission control and monitoring the next steps of tonight's flight, please let me now yield the floor to Sentinel-1b customers and partners. Thank you very much.
Ladies and gentlemen, on behalf of the Director of Earth Observation Program at ESA, Professor Volker Liebig, let us express our pleasure to confirm the separation of Sentinel-1b, concluding the successful launch. In the coming hours, we will have a lot of important activities to perform, so for us the night is not yet over. We have to deploy our solar array and open the radar antenna. But at this point in time, we can already confirm a successful launch, and this is a big moment for us. At this point, I would like to thank all of the teams involved in this complex endeavor, especially the ESA operation team in Darmstadt that are starting a very long and delicate night, to the launch team, and to Arianespace and their Russian colleagues. Merci, spasiba.
Good evening, ladies and gentlemen, Monsieur Prefet, distinguished guests. What an emotional moment Sentinel-1b is in orbit. Well, first of all, let me convey the congratulations and the thanks of our DG, Laurie Evans, to all the teams, that is to say from ESA, from Arianespace and CNES, the many teams behind me, whether they also still in it, working through the night tonight to look after our Sentinel. A great thank you to all, and I should also convey her thanks to the colleagues of the European Commission who are not here and who have worked so hard to achieve this goal. Again, European space industry has shown us how it is excellent in providing us with an outstanding satellite and mastering the challenges of space. This is another great success for Copernicus and all its many partners that are participating in providing both the space component and the services. This will further raise Europe's capacity to address global challenges as well as the societal challenges that are involved. Let me make no bones about it. Copernicus is ambitious. And with the launch of Sentinel-1b, we have raised the threshold and stepped up the pace of delivering data from space. This launch has doubled Europe's access to radar images for day and night at all weather conditions and has reduced the revisit times to a timescale of 1 to 3 days. In the equatorial regions we'll be up to 6 days, but nevertheless, this is a huge advantage for our services. 4 satellites are now in orbit. 6 Copernicus services are operational and are computing bits and bytes from the satellites, deriving higher information available to the public at large in a free and open data policy. This means that it is available to businesses to make further products, that it is available to citizens interested in forecasts of the atmosphere, interested in the state of the environment around them. Our Copernicus land services are already providing global data on the state of vegetation. But this satellite and the amount of information available will further raise their capacity to monitor the forest canopies, particularly in areas under cloud cover, which, as we see in the tropical regions, is a lot of the time. The Marine Environment Service is providing 7-day global forecasts of the state of the oceans. And of course, such an exercise of forecasting is hugely enhanced by the appearance of yet another satellite providing information on the sea ice extent, the ice drifts, the ocean currents, and thereby it is able to help shipping determine the best routes to take. Staying with the oceans for one moment, the Maritime Surveillance Service is relying critically on radar satellites for its real-time information of what is happening. It can therefore better monitor the traffic and the associated pollution events on the seas. We already heard about the Emergency Management Service. Well, on the one side, it will profit from the timely radar data that will tell it about land movements, about flood events, and therefore it will be in a better position to assess also the risks and therefore anticipate events. On top of this, in the case of a disaster, its response time will be hugely reduced by having access to additional data, as I say, above Europe, between 1-3 days, across the world within 6 days. The impact in the long term of this satellite is, of course, also huge, because climate change is something that is being addressed globally by many parties and also by the Copernicus services, which rely on such information as how our ice cover in the Arctic is developing and changing. All this has, after all, now been made with priority from EU budget, that is to say, with taxpayers' money. Copernicus funding is secure for the next few years, in the current funding period up to 2020. However, satellites are being manufactured at this moment to provide our needs up to 2030, and a further 5 satellites are to be launched until the end of the current funding period. On top of this, we should also remember Galileo is advancing and will be providing initial services this year. In this situation, it is now time to look ahead and to prepare the future beyond 2020. And the future space policy is one of the priorities of the Juncker Commission. and our Commissioner Bieńkowska has just launched a public consultation to set the direction for the next 10 to 15 years. Based on this, a strategy document will be prepared for later this year to ensure that our space activities and space will provide services and that these serve European citizens. Now, before closing my short intervention, I should also like to wish the other teams the success that I've just experienced, because they will still have to wait for hours for that triumphant moment when their experiments will separate. And I think this is a wonderful opportunity that we can have both educational satellites, a scientific mission, and an operational satellite on one launcher. And I should like to thank both Arianespace and all the other industrial partners, first of all, of course, Thales Alenia, for cooperating in this wonderful fashion. Thank you very much.
Mesdames et Messieurs, ladies and gentlemen, dear friends, good evening to everybody. Well, that was a great launch, but from Thales Arianespace, let me express the congratulations to everyone of the European Commission and the European Space Agency. And congratulations in particular to Arianespace and CNES. We know that we can rely on them for such a kind of well-done job. Sentinel-1b is now starting its life and joining its twin satellite, Sentinel-1a, that was launched about 2 years ago. I have also a thought for Sentinel-3a that was launched a few months ago, going to include inside the constellations of satellite of Sentinel family. I'm sure you can understand that the Sentinels are close to our hearts. And this is a big day for us. In this moment, I would like also to thank our colleagues of Airbus Defence and Space that contributed a lot for the radar instruments on board of Sentinel-1. The successful development of Sentinel-1 is thanks to the contribution of about 700 people and from about 60 different companies in Europe. Thales Arianespace led the consortium as prime contractor, and we had about 400 people working on this project from our industrial sites of Rome, L'Aquila, Milan, Madrid, Charleroi, Toulouse, and Cannes. But Thales Arianespace is also on board of Soyuz. Teams in Belgium are providing, in fact, the safeguard system of Soyuz. So it's been a big job. The teamwork with European Commission and European Space Agency has been great. And we are really proud to work on the next segment of Sentinels, C and D, for which Thales Arianespace is prime contractor for Sentinel-1 and Sentinel-3. We have been making Earth observation instruments and satellites for many years, and in that time we have become world experts in the field. But today's launch is not finished. I would like to offer my best wishes to our fellows passengers who are still on board, CNES for their microscope satellite, and all the students who have built the 3 CubeSats as part of ESA Fly Your Satellite project. You guys are the future of our industry, and maybe you will come and work for Thales Arianespace one day. Why not? So thanks to all the teams involved in Sentinel-1b, and congratulations again to ESA, the European Commission, for their continued trust and confidence. Our teams are now going to start a very busy night, and so thanks to all, and thanks to you for your attention.
So indeed, we will have a long evening. So we will be back in little less than 2 hours to attend the next major milestone of tonight's mission, which is the separation of the 3 CubeSat designed and manufactured by 3 European universities in the frame of ESA Academy's Fly Your Satellite programme. So thanks for your attention. La soirée a bien commencé et on attend maintenant qu'elle continue aussi bien pour nos amis étudiants et naturellement pour le CNES avec microscope. Merci beaucoup.
Congratulations to the Sentinel-1b teams. They're really something to be proud of this evening. So our first part of the program for this evening is coming to an end, but this is only the first part. Remember that we have still 2 more missions to deliver. So we will be coming back in just under 2 hours from now to watch the second main milestones of the evening, the separation of Fly Your Satellite. We will be coming back at the 23 hours and 43 minutes universal time. For our friends following from Europe, we will be 1 hour 43 minutes Central European time, which corresponds to 20 hours 43 here in Kourou. So it's a little bit less than 2 hours from now for the second part of our program, the separation of Fly Your Satellite. For now, goodbye.